All right, so today we're in section 5.4 and studying equilateral and isosceles triangles. All right, tell your neighbor what an equilateral triangle is and what an isosceles triangle is. Okay, now brainstorm all the different things you know about those triangles. Okay, if I have an equilateral triangle or an isosceles triangle, let's start with an isosceles triangle. Isosceles triangles have two sides that are congruent. The thing that a lot of students forget about isosceles triangles is that they also have two angles that are congruent. So if you have these sides congruent, these legs, okay, then those angles that are opposite those legs are also congruent. Okay? So if this side's congruent to that side, this angle is also congruent to that angle. Or if this angle is congruent to that angle, then that means that side is congruent to that side. Okay? So the isosceles triangle has two sides congruent. What's the difference between isosceles and equilateral? Yeah. Equilateral have all sides congruent. Okay? Equilateral has all sides congruent, which means it also has all angles congruent. So equilateral, we also call equiangular. Is an isosceles triangle an equilateral triangle? Is an equilateral triangle an isosceles triangle? Yes. Okay, an equilateral triangle has two sides congruent, just so happens to has a third side congruent. It's a special type of isosceles triangle. It's a more specific type of an isosceles triangle. It's kind of like the whole square rectangle bit, right? You guys know what I'm talking about there? Like, are all squares rectangles? Yes. Are all rectangles squares? No. A square is a special type of rectangle where all sides are congruent. Okay, kind of the same thing with isosceles triangles and equilateral triangles. Okay, questions there? So using some of those properties, what I want you to do is I want you to take a look at page 141 of your student journal. On the bottom of page 141, you have these problems, these four. So go ahead and work through those with your group. All right, so this was to get you kind of familiar with some of those theorems that I just kind of flew over really quick there. All right. NJ is congruent to NM. So we've got here to here. Okay. How come? Or, excuse me, then what? What do we know? That's the case. Yeah, Sam? Good. Angle J is congruent to angle M. All right? Okay, so if this is congruent to that, then we know... Oops, am I hitting the wrong one there? NJ, NM, excuse me. Then we know that that is congruent to that. Okay? So if this side is congruent to that side, then those angles opposite. What are we using there? Which theorem? Oh, base angles theorem. That's what matters. Okay, base angles theorem. All right. Number 2. Volunteer there. Maddie, what do you got? Good. Angle M is congruent to angle N. So if this is congruent to that, then that's congruent to that. And what did you use there? Good. Same thing. Base angles theorem. All right. Number 3. Alex. Good. If these two angles are congruent, then we know that those sides, that one and that one, have to be congruent as well. Okay? So KM. And how come?
Because of the converse of base angles.
Good. Like you want to call on someone? Yeah, go for it. Oh, Brian. Well, that's a good friend right there. Including you, Brian. Okay.
LJN is congruent to LJ, then line
Okay, line LN is congruent to line, almost. I think it's LN to LJ, I think. Right? So if we know that this angle congruent to that angle, so that side congruent to that side. Okay? And same one, right? Converse of the base angles theorem? Same thing. Okay. Any questions there? Just getting used to those different theorems. All right. Let's apply them in actual problems here. Turn the page, 142. Okay, we'll give number 5 and 6 a go. I want to get a couple volunteers up here, 5 and 6. All right, Maddie, come on up. Drew, come on up. All right. These guys.
Can I use your pencils? Oh, you sure?
Oh, yeah, I'm gonna need it. Talk to me. She broke her phone.
I broke my hand.
Wait, no, I need to. There you go, Drew. Pencil. Oh. Get it. Not yet. This is all food.
All right. Guys, go ahead and make sure that you check your work off there.
I honestly think I did that wrong.
There we go. Okay. Number 3, x equals 31. It's an equilateral triangle. All sides are equal. Well done there, Maddie. And then number 6, we know that 2x equals x because, 2x equals x? Not sure on that one. Oh, 2x equals that x? Oh, so this angle. Can't quite do that. No. We are true. This does equal that. So all these are 2x, right? Because this is an equilateral triangle. That means 2x plus 2x plus 2x equals how much? 180. Okay. Hey, that's all right. Drew, thank you for coming up, giving it a go. All right. Any questions? Thank you for going up there, Drew. Number 7 and 8. Give them a go. Work together. Okay, any ideas on this one? Yeah? You think y is equal to 75? Why?
Because, okay, so, if it's an equilateral triangle, then everything is split evenly into 3. So, if a triangle is 180 degrees, then you have to split it all into 60. And then if that corner is a right triangle, so.
Okay, hold on 1 second. So, you're saying that this is an equilateral triangle.
Yeah, so each angle is 60.
Okay.
And then since that you have that right angle, and one side's 50, that means the other side's 30.
Okay, if this is 60, that means this is 30 because together they make 90. All right?
And then so you have to subtract 30 from 180 to get the sum of the other two angles. And then you divide it by 2, and so it's 75.
Okay, so those two y's plus that 30 make 180. So 2y plus 30 make 180. So we subtract 30. So 180 minus 30, we get 150. And so y is 75. Okay, y is 75 degrees. I agree there. Okay? How do we get x? Maddie? Okay, so this side right here, this is an isosceles triangle, as Maddie said, because these two are congruent. Therefore, this side equals this side. So this is x over here, which also means this equals x. All of these sides of this equilateral triangle are x. And if we already know that y is 75, that means I have 75 minus 25 equals x. So x is 50. Well done. Good explanation there, Maddie. All right. Yes, Isaac? You got the next one? All right, number 8. What do you got? Okay, so that's isosceles. So that's x. Okay, hold on one second. We've got a lot you just said there. So this is an equilateral triangle. The sides are marked. Okay, so this equals that. All right. Well done. What's that? So, well, remember it's y equals 20. So that means 7. That means this side is 50.
But for since the top triangle, like the second triangle, since the two sides are congruent, shouldn't the angles down here be congruent too?
These two angles should be congruent.
Oh, not
Yeah. All right. Good job. Any questions?